Hi everybody, this is Travis Jarrett with TITANS of CNC, and today we're going to talk about the conventional OD micrometer. Now if you've been in a shop before, you've probably come across one of these micrometers. If you work in a shop, you definitely want to make sure that you know how to use it. Now, we call it a conventional OD mic because instead of using an LCD screen to tell what your measurement is, like on a digital mic, use graduated number lines right here to determine your feature of size. And it's called an OD mic because that stands for outside dimension, which basically means you measure something externally. So that can be a thickness of a part or perhaps a diameter, but when you measure, you're measuring on the outside of the part. Now this right here is a Mitutoyo 0-to-1 mic, which means that it measures from 0 to 1 inch. Now mics come in standard sizes. You can see right here we have a 4 to 5. Mitutoyo has conventional micrometers that go up to 80 inches. Now, the basics of the micrometer are you have the frame right here, which is where you're gonna hold on to. You have the anvil right here, which is stationary. This will rest against your part. You have the spindle right here that moves to make contact with your part. You have the sleeve right here that has graduated number lines on it and remains stationary. And you have the thimble that also has graduated number lines on it, but it rotates and it moves as the spindle moves. Now, a lot of times you also have a spindle lock right here, which does just what it says. It just locks the spindle from moving. And depending on the mic, this right here is a friction thimble, which when there's enough force, it will just turn around and the spindle will not move. You may run into things like ratchet locks, or some micrometers like this rely on feel only. So now when it comes to measuring with the OD micrometer, you first want to make sure that your surfaces are clean. Now, if you have a 0-to-1 mic, a lot of times you can use a piece of paper. You can stick it in between the anvil and the spindle, tighten down, pull it out. And you just want to check and make sure that it's reading at 0. Now, if it's not reading at 0, you may want to talk to somebody in your shop, and there are ways to adjust the spindle and the sleeve to make it do such. Now, if you are using a mic that's bigger than a 0-to-1, you can't do that, right? So if you have a 1-to-2 or this 4-to-5, you'll want to use some sort of gauge block or perhaps a standard like this to make sure that you're starting from an accurate place. When you go ahead and measure, you're going to make sure that your faces are perpendicular to the face you're measuring, which basically just means they need to be nice and flat. You'll come in, have nice and good even contact between the faces of the anvil, the spindle, and your part, and make sure that you're applying the right amount of pressure. Now once you've made nice even contact and there's no rocking between the tool and the feature of size that you're measuring, you'll want to go ahead and read these graduated number lines to see what your measurement is. Now to understand the conventional OD micrometer, I find it easiest to take it from the largest to the smallest. If you look at the micrometer, you have graduated number lines, and these lines on the sleeve right here are broken up into 10 different sections. You can see 1, 2, 3, 4, all the way up to 9, and then when it gets to 10, it reads a 0. Now if you're reading these numbers right here, and we want to say we're at 100,000ths of an inch, then we need to make sure the numbers here on the thimble are at 0. All right, so this 0 right here will line up perfectly with this horizontal line along the sleeve, and it will be right at the 1. So right there we have a 0 here lined up with the 1. That's 100,000ths of an inch. If I want to be reading at exactly 200, I will be at the 2, but I have to make sure that there's a 0 lining up with that horizontal line along the sleeve. Now in between these deviations, the 1, the 2, the 3, the 4, etc., there are further divisions in between. There are 4 sections. Each one of these smaller divisions stands for 25,000ths of an inch. Now we're going to go ahead and discuss the graduated number lines that are on the thimble right here. Now so far we've had you line up this 0 with this horizontal line right here, which puts us either exactly at 100,000ths, exactly at 25,000ths, and so on. But now, what if our measurement is in between right here, right? So what we have is we have 25 deviations going around this thimble. So if I go down to 0, if I open this 1 deviation, and this 1 is lined up exactly with that horizontal line, I now have a gap of 1,000th of an inch between my anvil and my spindle here. Now as I continue to rotate this around, these numbers grow, as does my gap right there. So as you might have guessed, each time we make one rotation from 0 to 0, that takes us to a new smaller deviation line of 25, and if we do that 4 times, that takes us out to one of the larger deviations of 100,000ths. You can see this when you come all the way down to 0. The 0 right here lines up perfectly with the horizontal line on the sleeve right there. So if I move this 1, that's at 1,000ths of an inch. That's at 2,000ths of an inch. So on and so forth. We'll move around 25 times until we get to the first graduated line of 25 thousandths. And if we're somewhere in the middle it will be whatever the last graduated line we saw plus whatever we see on the thimble. So if I was to move 5, I would have 50 plus 5, 55 thousandths of an inch. So if we're here, how would we read this? From here, I want to read from the largest to the smallest. So I read out, I have a 1, which is 100 thousandths, a 2, which is 200 thousandths. I have one 25 thou deviation exposed, so that would be 225 thousandths. Now I don't quite have the second line exposed. Now if the second line exposed, it would be 250, but we're not there, right? So we have 2 plus 25 plus whatever number shows up on the thimble right here. So that would be 2, 25 plus 21 is 46. So this is 0.246 inches. Now, as you might have guessed by now, you can see that that 0 will line up every time it makes 25 rotations, because on the thimble right here, we have 25 segments. So we're at 0, we're at 225, now we're at 226, 227. If you need to be more accurate, some micrometers have a vernier scale on the back. Now the vernier scale will allow you to measure down to the 10,000th of an inch. Now the way you will do that is you will look at this mic, you have vernier lines here, and you have lines on your thimble right here. What you do is look at those lines and you find the first line that lines up as close as possible with one of the lines on the thimble right here. So if we look, we can see the 0 is kicked off, the 1 is kicked off, the 2 is kicked off, the 3 is kicked off a little bit, and the 4 right here, maybe just a little bit, but not quite as much as the 5. So I'll go back, I say the 4 is at the closest. And so now I will read this as 0.3 plus 3 lines, each 25 thousandths each, is 300 plus 75 is 375, plus my 16 takes me to 391, plus 4 tenths, which leaves me a measurement of 0.3914. Now for a couple examples. Coming down here, make sure it sits nice and flat. Pressure is good. All right, so we have 1 all the way up to 7, so that's 700 thousandths. We'll add the next line, which is 1 of the smaller divisions in between, which is 25 thousandths, or 725. And now we go over here, because we haven't quite made it to the second one, so we're not quite at 750. All right, so we'll do 25 plus 23, all right, which takes us to 48. We're not quite to the 24, all right, so I would say 0.748 and roughly 8 tenths. Now usually your eye is going to be pretty good depending on the tolerance you're measuring. This is plus or minus 5, so that's good. But if you do need more accuracy, you can use these vernier lines back here. So for measuring a diameter, the principles are similar to a thickness measurement or something that's on flat faces, right? We're looking for the highest measurement. We're going to come in nice and easy. We're going to rock it so it sits nice and flat, trying to find the highest spot. And here we will read again. So this time we have the number 8, so that's 800 thousandths. We'll count the smaller lines at 25 thousandths each at 825, 850, 875. And if we look at the graduated number lines on the thimble, we're just above the 14, so we'll add 14 to that 875, all right, which takes us to 889, and probably a tenth is what I would call that. And that's how you read a conventional OD mic. Now, if your OD mic is starting to stick a little bit or something like that, and you might have some grime in there, you can go ahead and use a cloth and some alcohol to clean it up. We recommend if you're not going to be using it for a little while, you store it in the case. If you do have a 0 to 1 mic though, and you're going to store it, make sure you leave just a little bit of gap between the anvil and the spindle there. So the question, when to use the OD micrometer? So the OD micrometer is one of the more accurate tools that you will find in a machine shop to measure features of size. Now this will be kind of up to maybe shop procedure and whatnot, but if you're looking for exact specifications on accuracy, you can usually find these in manufacturer's manuals. This particular 0 to 1 right here is rated at 1/10,000th of an inch, plus or minus. Now as a general rule though, as your micrometers get larger, you'll want to watch out because their accuracy usually decreases. Again, I'm Travis Jarrett. I want to thank you again for joining us today. We hope to see you in another video.